Hey guys, it's Miss Muse here, just giving you a short lesson on matter. In fact, today we're going to talk about classifying matter. So, what does it mean to classify? I would say, a good example of this is what may go on in your closet at home. Maybe you have classified your clothes in a certain way. So, for example, you may classify your clothes by color, you may choose to classify it by item, and so on and so forth. So there are different ways of classifying matter, and it's important to do that because then we can kind of group things together and know more about them based on how they're grouped. So you'll remember from earlier this week that we talked about matter as being anything that has mass and volume, but we're going to group those, further classify. All right, so matter, we can divide it into a group of materials called pure substances. And pure substances, by definition, are materials or types of matter that contain only one type of particle. And I'm going to talk a little bit more about that and give you some examples about what I mean by that. And of course, if we're talking about the types of matter that contain only one type of particle, then there must be another type of matter that's going to contain more than one type of particle, and that we give the name mixture to. So again, taking matter, we're going to break it down into pure substances or mixtures. Okay, so let me start by giving you some examples that will help you to differentiate between these two. Sometimes it's not obvious, but we're going to start you off with some examples that I think will make sense to you. So I want you to imagine that you have an iron nail, and that nail is composed entirely of particles of iron, right? So if you were to zoom in, that's exactly what you would see, atoms of iron. So that contains only one type of particle, which is why I've placed it in the pure substance category. Conversely, if I were to let that iron nail sit out for a certain amount of time, maybe even in some water and with some salt nearby, then I might see that iron nail start to rust a little bit. And so I no longer have a pure substance, I have a mixture, because I have not only the iron that's still there beneath the surface, but I've got this other material, this rusting, which is iron oxide. Okay, so there are at least two different pure substances that are making up this mixture. I'm going to give you some other examples too that are a little bit more complicated. So a pure substance and a mixture, the difference between them is not always very obvious, as it was in the example of the iron nail and the rusty nail. So I want you to envision that you have a glass of pure water, and we're going to, the glass is there to hold the water, but I'm really just concerned about the contents of the glass, and we're going to assume that every particle in this glass is a molecule of water, right? So if we zoomed in on one of the droplets, we would see all of the particles looking exactly the same. Right? So that's a pure substance because I don't have anything else besides pure water molecules, H2O, in that little droplet. A mixture, on the other hand, a good example of that would relate to this former example would be ocean water, right? So ocean water, even though it may not look on the surface to be too different from pure water, within that, I'm going to have some salt there, probably some other minerals as well. I might even have some visible components there that are separate from the water, like algae, for instance. Right? Another example to kind of go a little bit deeper with this would be bottled water. So bottled water is not pure water. It may contain a number of different minerals in different amounts. Now it's kind of hard to see, so I'm going to help you focus here on this, but this particular label that was found on the water bottle that we're seeing in the image says sodium 5 milligrams. So what that tells me is that even though I can't see any distinct layers in this bottled water, that there, besides the pure water, there are also some sodium particles in there as well. So it is a mixture, even though it doesn't immediately strike you as a mixture. So just keep in mind that it may not always be obvious. Okay, oops. All right, so we're going to ignore that this is there because that's a bit of a flaw in my presentation. So let's do some examples to kind of group together, and I want you to ignore that because this may or may not relate to this example. So I want you to identify whether the examples that I give you are pure substances or mixtures. So a cup of coffee. In case you need to visualize this, here I've got my coffee there. All right, so take a minute to pause the video and come up with what you think is the right answer here. So in coming to my decision, these are the things that I would be thinking about. I would be thinking about, well, is this cup of coffee composed entirely of one type of particle, or is it likely to contain different types of particles? So I would say, well, I know there's water in there, but I know on top of that there's sort of the extract of the coffee. Whether I add milk or sugar, that will just add to my my conclusion that it's definitely a mixture. But even if the sugar and the milk or cream were not in there, I would know that this is still not a pure substance. Because again, it's got the water in there, the coffee extract, and so on and so forth. Right? So definitely a mixture. Okay, now we already know that my next example is going to be a pure substance. So even though you know it's a pure substance, I want you to figure out why a cylinder of nitrogen gas has to be a pure substance. Well, in making my decision, I would be considering, well, what would be the contents of this cylinder? If it's got a label on it that says N2, what that tells me is that this cylinder must contain only nitrogen particles, only particles of nitrogen, and nothing else in it. So if I know that that's the case, then I know definitely that it's a pure substance. Okay, so here's where we are so far: matter, pure substance, or mixture. Right? So what we're going to do is we're going to go even more narrower in our classification system here. So sort of like in your closet, maybe you decide that you're going to group all the pieces by color, but then within each color, you're going to decide to separate maybe the pants from the shirts. Okay, so what are the different types of mixtures that you can have? You can have what's called a mechanical mixture, sometimes also referred to as a heterogeneous mixture. What does that mean? These are kind of big words. What that means is that it will have more than one phase or more than one visible part. I like to think of it as having more than one layer to it. So right off the bat, I would say like an oil and water mixture would be a mechanical mixture because the oil layer would be highly visible and would be separate, distinct from the water layer. The other type of mixture that one might possibly have is the one that only has one phase or one distinguishable layer. So that would be an example. A good example of that would be like a cup of tea, right? So I know in a cup of tea I've got the tea extract, but I've got the water, but I can't really see where the water begins and the tea ends. Not usually, anyway. So I'm going to use the examples that we looked at earlier, and I want you to pause the video and think carefully about where you would classify the rusty nails and how you would classify this bottled water. Okay? Would you classify each of these as a mechanical mixture or a solution? So I'm going to explain to you how each of these items would be classified, and if this makes sense to you, awesome. And if it doesn't make sense to you, this is one of those burning questions that you're going to come to me tomorrow in class and we're going to have a discussion about. So in deciding where the rusty nails need to be placed, I need to say, well, is there more than one visible or distinct component or layer right? So I know that if I cut this rusty nail in half, it's likely that I would see the rust layer, but I would also see beneath that a separate iron, pure iron layer. So to me, that is a mechanical mixture. The bottled water, on the other hand, and we talked about it having the sodium in there, but the sodium was invisible. We couldn't say, oh, here's a sodium ion, oh, here's another sodium atom, right? So to me, that, there's only one distinct or distinguishable layer there, even though I know it's not a pure substance. So I would put the bottled water, okay, the water itself, I would label that as a solution. Hopefully you did all right with that. Don't worry if you struggled with that. We can definitely have a conversation tomorrow. So let's do a few examples. So what I want you to do here is I want you to take a look at the examples that I've created, that I've put down here, and I want you to, even by using the picture, try to figure out, just make a decision about whether you would classify each of them as a solution or as a mechanical or heterogeneous mixture. And be prepared to justify why that is. All right, so hopefully you've thought about this, and when you look at this little chunk of asphalt, I can see for sure that there's some different types of rocks in there. The colors are different, and they're definitely in a separate or distinct phase as compared to the black kind of tarry stuff in the background, right? So that, to me, quite obviously must be a mechanical mixture. So let's think about apple juice now for a second. I want you to come up with your own decision about this, so pause the video again, and then we'll discuss. So when I look at this apple juice here, I'm just strictly looking at the juice itself. I'm kind of ignoring this straw, and I don't really care about the glass. I'm strictly looking at the juice here. When I look at the juice, I can't see, I know that there's sugar in there. I know that there must be some kind of color coming from the apple, and then there's the watery background, right? So even though I know that this is not a pure substance because there are a bunch of different particles in it, I know that it is not a mechanical mixture because it doesn't have sort of distinct chunks in it or layers. So I would definitely classify this as a solution, simply because to me there's only one distinct layer here. So what I'd like you to do now, and I'll post this in Google Classroom, there are a couple of practice questions that I'd like you to try to work through on your own, try to figure them out. So question number 1 asks you to distinguish between a pure substance and a mixture, and provide some reasonings. And question number 2 asks you to identify each of the examples as either a solution or a heterogeneous mixture. Now, alloy, I'm going to add to this. What I want you to do is I want you to research what an alloy is, and then see if that helps you figure out how to categorize it. If you have any questions, be sure to send me an email tonight, or alternatively wait for class and ask those questions, and we'll do the best that we can to make this clear and understandable for you. Good luck!